All right, welcome back to another network automation video. Where I left off last time, I had done quite a bit of reading. We finally got into the actual hands-on stuff. It's going to be pexpect, which unfortunately is not something you would be using if your intent truly was to master network automation. As I've mentioned multiple times, I'm a bit unhappy with this book. The way it is kind of misrepresented by the title. This is very much a network automation book for people who have had no experience in network automation at all. That's why we're learning expect. That's why we're using Telnet. It's really an inappropriate book for anyone who really does want to just master network automation so that they can use it in the most effective and useful way possible in production. But that aside, let's continue. So where I left off, we were setting up these devices. We're going to need to enable Telnet on them. We're going to need to find a different way to get management on them. The way they were set up in the lab, there's a special VRF network, so management has its own routing table, but our devices here don't support that VRF configuration. So I'm going to have to find a different way to enable management on these. So this is going to be 000 is OBB management. So let's hook that up. Oops, and I got the wiring wrong here. Let's see what the wiring is on router 2. Oh, so it looks like I'm going to need another interface on my Ubuntu server. And I've got to delete the existing connection in order to add that other interface. All right, so now I can wire this up. Okay, well, that's interesting. It says that it does exist. Oh, it doesn't exist on the actual VM. So preferences, QEMU, Ubuntu server, edit. Yeah. Like you can have more here and then just allocate a few of them there. Let's do that actually. Let's give this like 10 interfaces. Okay, and then this will only have 3 of them. Okay, so now let's wire this up. Oh. Did I not save it? I saved it. Maybe it's got to be restarted. Yeah, unfortunately, yeah, I'm pretty unhappy with this book. You can see I'm about, maybe not a complete fourth of the way through, but I'm definitely about an eighth of the way through, which I think is kind of a significant section of the way through. I mean, I'm more than, if I'm 1/8 of the way through, I'm about 20% done with the book, right? No. I'm going to do the math. Oh yeah, well I'm over, so I'm about 12.5% done with the book. So it's not. I've definitely got more to go through. So I guess I'm really judging it by its cover at this point. But I haven't learned about Git. I haven't learned about advanced terminals like IPython. I haven't learned about like Jupyter, which is good for sharing code. There's just so many things this book hasn't touched on. And for a book about mastering network automation, I'm kind of upset that it hasn't. Perfect. Okay, now we're good to go. I want that terminal to come back up. Hopefully I don't have to change the zoom every time. All right, so now hopefully after the reboot, it's going to go in, and it's not. Well, that's interesting because we added it. I mean, we can see very clearly it does exist. We've got 10 adapters. Oh, you know what? This is something I've seen before. So yes, in this Ubuntu VM, yes, it does exist. But this one was created before we made those changes. So this one only has one port. So we got to put up a new Ubuntu VM. That's the problem. So now this one's going to have 10 interfaces. So it's kind of going to be a little bit ungodly, but better than it just not working. In fact, you know what? That's a bit too ungodly for me. I'm going to get rid of this. And then I'm going to change the preferences. And it's going to be nice and pretty with only 3 adapters. Which of course means I might have to change it later, which is not going to be fun. But I'm the kind of guy who likes things to be as free as clutter as I can. At least as long as is possible, which is usually not very long. Okay, now we're good to go. Okay, finally. So yeah, we're gonna have to, I think that whole VRF thing they had, let's see here, let me look at it in more detail so I can figure it out. So yeah, they had a VRF instance called under this, so this only belonged to the VRF. But in the VRF, it was just, basically it's just saying that the only thing this interface can do is talk across the link. It won't be participating in OSPF. It won't be doing anything else but that. So it's just kind of an extra taking it off the network and having it be used only for management from that Ubuntu server. It's kind of an extra safeguard or a sequestrization of that port. So we won't have that, but I don't think we'll need it. I mean, as long as we're not including that in our OSPF protocol or in our BGP, we'll be fine. There might be some cases where if they tell us to include the whole Class B private space, we'll have to make sure that we're configuring it in a different way so we're not including our management to the Ubuntu server. All right, so let's configure the Ubuntu server now. Unfortunately, it's going to need some configuring. Oops, taking a while to come up. Hopefully everything looks good on here. I think it does. I think I remember everything looking pretty good. Looks like the ports are still admin down though, so we don't want to bring those up. But everything looks good to go on the interfaces. All right, it's router 2. All right, so those ports are up now, so we should have management. We are going to need to configure the server though. Oops, and it looks like activation of network connection failed, so I'm not sure what that's all about. Looks like, oh yeah, because I've made a new instance of it, so it doesn't have the updates anymore. Let's see if we can get here we go. So if we can get the terminal up, it looks like that's going to be more difficult than I had anticipated. All right, so not too difficult in the end. Hopefully we've got internet connectivity. We'll test that by pinging the Google DNS servers. We do, excellent. Let's look at all of our interfaces. We should have 3 of them total. So yep, I see 3 of them. For some reason it starts at 3, but that's okay. It's just going to be 3, 4, and 5. 3 that got a IP address on my private home network, local area network that's connected up to my internet service provider here to access the public internet. But these ports need to connect to the lab. So I'm assuming 4 is port 1 and 5 is port 2, but we'll see once I configure them. So I have config, add, and then I'll need to look up what it is. So show run int fa00, that's going to go to to the Ubuntu server. OBB management is the description on that. So it's going to be 172.16.1.0 is the network it belongs to. So I'll just configure .1 on the server. Oh, right. I've got to do, so what was it, ENS4? Let me get the help on this. Oh, okay, that worked. Why wouldn't it let me give it a subnet mask? Unknown host. Invalid arguments. Cannot assign requested address. What subnet mask did it even choose? If I didn't give it one, probably a /32. Yeah. Yeah, I think it's a /32. Oh, it looks like it added a brand new address or a brand new interface. All this. Oh no, that's the one. So I'm just gonna do a quick Google search. I can't believe this is so difficult, but add an IP address to Ubuntu. So I don't get why this is so difficult. Like it was easier on the, yeah, I think I'm just gonna use the GUI. So what is it? It's up there, wired settings. Okay, got it. Here we go. So ENS4. So wired settings for ENS4. We're gonna go with, yep, configure this. And then it's going to be manual. Aha, here we go, netmask. 255.255.0. We don't need a default gateway. It's just gonna go across the link. So this is all we need to get management access to the box, but we do need to configure ENS5 as well. And I'm not sure which network address this belongs to. So 16.1.21. Oh, that's interesting. But this was 16.1.20. How does that work? Well, maybe it'll let me do that. Okay, so, okay, let's follow along with the example now, and hopefully we'll have the same results. So where we left off, we were right here. So we're going to be making sure we can get telnet to each of the devices. So we're going to need to be in our virtual environments. So let's go back and do those steps that were done before, including the one that took forever. Let's see here. Let's not, well, yeah, let's do them all. So let's start with yeah, let's start here. So this might take forever, unfortunately. Sudo apt update. And then I think the sudo apt install was the one that really took a long time. I can probably do the reading while that's going and then just come back and do the examples later. I think I'll do that. So even now, it looks like it's only fetched. Well, it looks like it's done now. So this is the one that takes a long time. So yes, and I want to install that. So yeah, we're only at, oh, well, it's moving a lot faster now. We're already at 20%. So I guess I'll just wait on this one. But I think this is just the first part. There's multiple parts. Once we get to 100%, we'll just be going on to the next part. I'm pretty sure that's why it took so long last time. There's just a lot of parts and it doesn't show you all the parts. So yeah, it looks like once that value on the left-hand side that you can barely see because of the default coloring scheme on this is done, yeah, now we've got another progress bar and this one's going much slower. So I think I'm going to keep reading. So we see they did a telnet connection, verified it, so we're going to have that up and running really soon. And then they entered in their username and password. I used Viral AutoNet Kit to automatically generate the initial configuration of the routers, good for you, which generated the default username Cisco and the password Cisco. Okay, did you string up a topology of 10 VMXs is my question. Noticed that the user is already in privileged mode because of the privilege assigned in the configuration. Yes, yeah, so that's an important thing to note. And again, you know, this is where this book got a strike for me. That's very, very, very much a unicorn environment where you can do that. The environment I worked in, despite having being the person who enters the config in every day, despite having the certification experience and training that I have had, I was not in charge of what went on the boxes. It was a different entity. And if I did not put on the boxes what this different entity said was meant to be put on the boxes, I was considered to not be doing my job properly. And I very well could have been the subject of disciplinary actions. A lot of the things this entity said to put on the box were things that if you put on the box, you know, it's back to that analogy of working for a ditch digging company, but not being allowed to use a shovel, you know, let alone a cell backhaul, you know, in the modern day of construction. So what do? Do you use your hands? Do you use your feet? It's really ambiguous how to handle a situation that is designed to have you fail. But that's something this book doesn't talk about, which is a big knock against this book. There's another book. I'm actually going to bring it up because of just how much better this book is. I don't think I'm going to switch over to it yet, but it would be nice if I could go over this book before I start my job on the 25th. Unfortunately, I have picked the other book because I thought it would be a better choice. But I think it's becoming apparent now that this book here, Python for DevOps, would have been a better choice. And you can see in the table of contents, they have a whole section devoted to, oh man, it took me away from the table of contents. Even though I clicked on the table of contents, it did not do what I wanted it to do. Okay, so here's the table of contents. If I go to the kind of end of the table of contents, you can see there's a whole section devoted to, where is it? I don't see it. Aha, DevOps anti-patterns. So this is where, unfortunately, you'll be most often gaining your professional experience is in an environment where there are persistent anti-patterns. And this book doesn't really tell you how to overcome them, but a lot of what happens in IT is people are in these environments where, you know, there's these anti-patterns, there's these very serious transgressions happening, you know, digging a ditch without a shovel. First of all, it's how you want me to dig a ditch for you if you're not going to give me a shovel. Can I bring my own shovel? I can't bring my own shovel. What do I do? Oh, I use my hands and feet to dig the ditch. It's like, you know, I don't want this job anymore. A lot of people, that will happen. They'll throw up their hands and they'll get a new job and leave gracefully, or they will just kind of walk out. But this book actually addresses that, which is why I think this probably would have been a better choice. And it talks about the many horror stories and anti-patterns you can see on the job. You know, ideally we would all work in those unicorn environments that allow us everything that this book says we'd be able to do. But professional experience is often hard to come by and very valuable. So even if it's not even if it's not the unicorn environment that you had hoped it would be, just having any sort of professional experience can be very, very valuable. And as I mentioned before, war stories, horror stories, those can kind of be badges of honor in the IT world. Yeah, but I really love this book for calling these things out and not just saying that, and not kind of giving you a false sense that you will be able to work in an environment where you are expected to do things that are able to be done. There's a lot of environments where you will be expected to do things that there is no way for you to do unless you do things differently than you are allowed to do them. And those are really sad, unfortunate situations, but they're things that are just never going to go away. And this whole book has a whole section devoted to them. So I love this book. I don't know why I picked the other book. Kind of a poor decision on my part. I thought this book would be better, but I kind of wish I were reading that other book now. All right. So, but this book only has one strike, 3 strikes it's out, but it's only got 1 strike so far. And we're moving on to the more good hands-on stuff. So I'm just going to continue to give it a chance. So I got to move back to the setup stuff now, though, since I had to recreate that server. Let's move into a different folder. So how about documents? And then let's make a special folder for this book, and we're going to name it the name of the book, which I unfortunately have forgotten. Oh, Mastering Python Networking is the name of the book. No wonder I forgot that. So it's going to do Dear Mastering Python Networking. Okay, so now we're going to be following along with the example. We're going to do Python 3-m VNV, and we'll name our virtual environment VNV. Oh, yep, and I remember this was from before. Sudo apt get install Python 3 VNV. I remember this didn't take too long. Just a minute or so, which is better than the other one that took much longer than that. Yep, and it's already done. So now let's make the virtual environment, Python 3-m VNV, VNV, and let's activate this virtual environment source, VNV bin activate, and then let's use that which keyword to see our directory to that virtual environment. You know what? I'm kind of tempted to. I'm gonna just put it where they have it, because they clearly have it just in their home directory, not in a special file, and I just want to mimic what they're doing. So I'm going to deactivate. I'm going to go back. I'm going to do rm-rf on that one I just made. I'm going to go back again, and then I'm going to make it exactly how they made it. Oh, right, I skipped a command. Okay, so now we're good to go. We've got a similar path as they have in their examples, which I would rather deal with that. Okay, and then they deactivated theirs, but we're not going to activate ours because we're going to do a pip install on pexpect. Yeah, I guess the reason I picked this book is because I was hoping I'd be able to get through it pretty quickly. Because the other book was just leaping through it. It's like, oh, it's so packed full of just valuable, wonderful information. I think it might take me a long time to get through, and I only have a month before I start this new job. So I'd rather just go through something I can get all the way through than kind of be halfway through this book and then have to give it up to focus on work stuff. All right, so now we're where we left off before. Hopefully it'll be more clear sailing ahead. Aha, so yes, wonderful, perfect. So, oh, let's do everything that they wanted us to do. So they wanted us to, let's see here, clear. And then, of course, telnet in there. And then we're going to do a show run, include Cisco. And yep, so sure enough, I entered in my username, I entered in my password, and I went right to the pound prompt. And here you can see it, username Cisco, privilege 15. So I got max privileges. the moment I logged in because I've got privilege 15. So the auto config also generated VTY access for both telnet and SSH. So show run pipe section line. So here's all the, I don't think it did do the full for SSH because I'm not sure if I have keys. I'll try it. Nope. Yeah, I don't have keys. It didn't do the crypto key generate RSA command. But why don't I just do that now because I'm going to need it later. So. And I'm not sure. So let's see here. Oh, it's going to be modulus. Oh, yeah. Some of them you don't have the modulus keyword. Okay, and it'll tell me. So I'll do 2048. Oh, I think no matching key exchange method. Let's see here. So ls-al. Do I have a .ssh file? I don't. Okay, so I think I got to do SSH and then key gen. So it doesn't tell me what size it is. Oh, okay, here we go. It's 2048. Yeah, I'm not sure how you can do a different size, but we're going to have matching sizes on the Cisco and the Ubuntu VM. So I think we'll be good to go. Unable to negotiate. No matching key exchange method for Hellman Group 1 SHA1. So am I using a different kind of key exchange method on here? What about SSH key scan? What does that mean? File. So yeah, let's give it a host. 172.16.1.20. Okay, so it's SSH1.99 Cisco. So is it that my keys are not valid? Let's put this into Google and find out. Oops, that is not how it goes into Google. Oh, I don't have the clipboard shared between this VNC client and whoa, well, what am I doing? I have a Firefox browser right here in Ubuntu itself, so I can just do a Google search on Ubuntu if it would open, which looks like it's not doing that. Okay, there we go. So unable to negotiate, no matching key exchange method found. Yeah, so it's going very, very slow. Pretty unhappy with the result here. I'd like to just use my host computer, but unfortunately I can't figure out how to get the clipboard to share. Connection options. Let's go to connection options. And then disable clipboard transfer. Well, I'm surprised that's unchecked. If that were checked, I would uncheck it. Okay, well, copy rect encoding, what's that? I mean, I would think to uncheck this, but it is already unchecked. Yeah, I'm not sure how to do this. I wish I had a different, besides type BNC viewer, I wish I had a different one. Okay, so what is the solution to this problem? Oh, maybe I need to do service SSH restart now that I regenerated the keys. So I'm going to try that. No matching key exchange method found. Their offer, yeah. So we're not using the same key exchange method here. We're using, I'm not sure how to tell what we're using. Let's see what we're using. Let's do a SSH, and then is there like a SSHD? Like what is that? Okay. Is there like information I can use? SSH agents? Aha, here we go. So here's some information. But it's no information about whether or not we're compatible with what they're doing. Let's try another SSH keygen. And then let's do a help. And so, oh, maybe I didn't generate an RSA because I didn't specify RSA. So SSH keygen -B. Okay, so this is how you specify the size. 2048 RSA. Oh, it's got to be -T. Yeah, so you could see SSH is a pretty advanced thing, or at least it can be in networking. So yeah, we're getting Diffie-Hellman group 1, SHA1, but here it looks like we've got whatever we've got, but it's SHA 256. So we need to figure out how to make that 250 or just SHA1 instead of SHA 256. So already we're getting pretty advanced, especially when compared to Telnet. So Telnet is definitely a beginner's concept, and we can see that this is a concept you would learn if you wanted to actually master Python networking, which is what I wanted to do. So I was hoping that this is the kind of problem that a book that said it was about mastering something could help me with. But unfortunately, I don't see that sort of thing mentioned in this book. I think it is beyond the scope of the book. It's too advanced for the book. So yeah, I got to figure out how to make. So I'm gonna type it. Just type it in here. So their offer Hellman SHA. Hopefully that will work. Here we go. So how to enable key exchange. So okay. Yeah, and hopefully now you can understand why I'm kind of so upset with this book, even to the point where I'm considering no longer using it, for it assuming that you have access to this hypothetical unicorn environment where you don't get any issues like this. Like, this is most of what you'll be facing in the real world, is just issues like this where you're meant to connect to a device that is 20 years old, and you only have a modern device to do that, but the modern device is not backwards compatible with all of the features on the old device. So that is what I'm trying to do now. I'm trying to set up backwards compatibility using SHA-1 instead of SHA-256 on the Ubuntu server. I could also just go and see if there's a way to enable SHA-256. Oh, yeah. So if you do SSH version 2, you actually don't have to disable your keys, or you don't have to recreate your keys. But hopefully that fixed it now that it's using version 2. Nope. Yeah, it's the key exchange method that isn't matching. So here it says what you can do, but unfortunately that's not working for me. Let's look at that. Okay. Okay, here we go. So I think here it looks like I might be able to uncomment something that will allow me to use that. So we're going to look for okay, so let's do what the person there said and add a new section to this. So it's going to be legacy changes, and it's going to be rhythms, Hellman, group 1 SHA. Group 1 SHA1. Yeah, we don't need those other ones. And I'm not sure if we need ciphers, but I think we should be good with this. Yeah, let's just try this. So damn it. Okay, so let's copy this line. And now we're going to need to quit without saving it. Super user. Oops. Okay, now we're good to go. Okay, so hopefully this is all we need. So let's do that command where we restarted the SSH. So that was the command here, command 53. So now hopefully this works. I'm feeling it will not. It did not. No matching key exchange method found. Job failed because control failed with error code. Sudo. Okay. I don't know why this is failing. I don't know why it didn't copy it. Failed to start OpenBSD secure shell server. Well, that's not good. I would have hoped that it would not fail to start that. Oh, did I miss the plus sign? I might have missed the plus sign. Yeah, I missed the plus sign. God damn it. Okay. God damn it. I'm getting really frustrated, especially since this book doesn't help me at all with any of these kinds of issues, which are the main kind of issues that you'll be facing. Oh, I forgot an L. Okay, I feel better now. I don't feel better now. So what? Maybe if I try regenerating my keys. See, but it's still SHA-256. It's got to be SHA-1. So how do I generate it? So SSH key gen SHA-1. Yeah. How do I do that? Yeah. So SHA-1. Yeah. Oh, here we go. Oops. So SSH RSA. Okay, this is the how you do. And again, this is a legacy RSA key. You wouldn't generally use SSH SHA-1. So it looks like the way this is done is this is HRSA. Nope, we still got that SHA-256 key being used and not the SHA-1 key being used. I wonder if there's more options on the Cisco so that I can generate a SSH. So IP SSH, big string logging, max startups, port. So it's going to be RSA. Key pair name. What about crypto? So we got crypto key. We got all sorts of stuff for crypto. What about crypto key? Generate, decrypt, encrypt, export. What about generate? RSA. Generate a general purpose RSA key for signing and encryption. Generate separate RSA key pairs for signing and encryption. Let's do a general keys. And they can be exportable, they can have a label, modulus. Nope, we're still getting SHA-1. We need to get SHA-256, or we need to figure out a way to get the Ubuntu server to use SHA-1 because they're incompatible. Another thing we can do, and this is kind of at this point what I want to try, is use that other Cisco image, and maybe we'll have better luck with that because it will. It won't generate SHA-1. It'll generate SHA-256. So let's set up management here. We got our router 3, and we're gonna see if we can get SSH working on there. If we can, that's great. We'll move over to that instead. Yeah, and then the last video where I lost a bunch of time bashing my head against the wall was an SSH issue. So for a book to not give due time to SSH is really frustrating. There's really no reason to spend so much time on Telnet when SSH is what's going to, 1, be required by most environments, and 2, be a requirement from most environments that is impossible to implement or insanely time consuming, and so much so to the point that you will kind of lose all your time and energy just focusing on getting yourself off the ground. So to not be providing help and assistance with that is really disappointing, as I've mentioned many times before. All right, but I think we can get this off the ground pretty fast and see if this is going to help. Okay. All right, so now we're starting to get on our feet here. Oh, I thought I defined a domain name right here. Oh, it's shut down. Oh, it's at 21. God damn it. Okay. Okay, so yep, they're same deal. They're offering us this different cipher. Let me do a IPSSH version 2, and then try it. Nope, still nothing. Let me regenerate the keys after doing that. I thought you didn't have to, but you might. Oh, yeah, now it's. Yep, so same deal. It doesn't have to do with the version of SSH. It has to do with the cipher, which I'm not sure how to configure that. But that's proof of concept that we're not going to save any extra time by using a different version of Cisco, which is good. I'm kind of glad we can stick to these old images because they do go faster. But we still have a pretty serious problem here that we need to figure out, either how to make R1 use SHA-256 or how to make the Ubuntu server use SHA-1. So Cisco SHA-256. Yeah, how do I enable SHA-256 but I need to do it for SSH. Yeah, how to configure SSH version 2 algorithm type 256 on Cisco routers. So okay, let's go back and let's do crypto key. Well, let's go to configure private terminal. Configure private is Juniper. And we're going to do crypto key 0wise. Get rid of the key we've got. And we're going to do IPSSH version 2. Then we're going to do enable algorithm Oh, we don't have enable algorithm type. We don't have anything. Yeah, maybe we've got something on the line. Let's see here. So aha, I think I might have found it. So show configuration or show run. I found it, and this is bringing me back to networking school. So yeah. So I think what's happening is this is secret 5. So configure private username. Oh, sorry, configure config t, conf t, username Cisco, priv 15, secret. Oh, okay, never mind. Shoot. I thought maybe the issue was either I didn't have a user account or I specified that the user account use a certain type of encryption. Like I thought that's maybe where you decide whether you want to use 256 or 1 for the SHA. What about username Cisco, priv 15, and then do we have algorithm type? We don't have algorithm type. What about AAA algorithm type? AAA attribute. See, AAA is not for wouldn't specify the algorithm type though. I thought. What about password? No. Yeah, we don't have anything for the algorithm type. Yeah, but I think it is, this secret is, a SHA-1 secret, but we need a SHA. Yeah. We can see here, yep. This is an SHA-1 secret. That's why we're having this issue, but we don't have the ability to do an SHA-256 secret. We do have the K9, but yeah, look at how old this image is. It was copyright expired in 2005. So, shoot. So, I mean, our only option is very clearly to enable the backwards compatibility in this modern Ubuntu machine so that I can work with this old Cisco device and use SHA-1 instead of SHA-256. So Ubuntu SHA-1 SSH. Let's see how we can do this. So yep, legacy options. Yep. So lots of help for this. So SSH-O kex rhythms equals plus diffie Hellman group 1 SHA-1 and then Cisco at, and then it's a legacy host. So can see that the copyright expired in 2005. So yep, it's a really legacy host. But hopefully this is going to work. Looks like it's still thinking. I'm kind of wonder what it's thinking about. Oh, okay, yeah, it's not. Oh, okay, and that didn't work with this too. I think I need to set, oh, aha, okay, so here's a clue. No matching cipher found. So before I changed this file here, we were getting a different message. We were getting, let's see if I can find the message that we were getting. If we can, it's no big deal. Aha, yes. So we were getting no matching key exchange method found. Their offer this. So this looks really familiar to what I added to the key. In fact, to the config file. In fact, it is what I added to the config file. But I've got one more line to add to that config file. I've got to add these ciphers to it. But we saw in that really good example how to do that. So I'm going to copy that. I'm going to do history, pipe, oops, history, pipe grep, and conf. And yep, so this will bring me to that SSH, do the 7.9, and I'm in grep mode. So now all I need to do is do I mode, and then cipher, and now paste this in, and do a plus sign. I don't know why it's not going red. That's kind of concerning. Where's that thing I read before? I think this is it. Oh, it's got to have an S. Perfect. Okay, so now I might have to restart it. I don't know if I do or not, but I'll try it. I forget what the command was. So the history, pipe grep, restart, and then it's command 80. So big moment coming. Oh, and this is 21. We're working on 20. Okay, so now we went back to the old error that we've got, even though we had that error corrected, it's now coming back from the dead. Yeah, you can see we've got, it's good to go for that. We're matching what this person says. Oh, I bet you we've got to regenerate new keys. Oops. So history or control R, history, pipe grep gen. So yep, let's do command 89. And yep. Okay, so yeah, no matching key exchange method found. Their offer Diffie-Hellman group SHA1, which is interesting because we weren't getting that before. Then we added the cipher command, and now we're back to getting that command. So I don't know where that came from. What if I get rid of the plus sign? I don't understand why there's a 1 there now. Did it actually make it in? Why is there a number 1? Okay, well, there isn't any more. Aha, SHA1. I think I think we're oh, so it's just probably not Diffie-Hellman group 1. Um, well, um, hmm. Um, so let's see here. SHA. Um, let's see. 119. Oh, I think I do want the plus sign. I wonder why it wasn't giving me. Yeah, like if I go like this. I don't understand why literally nothing is working. Like I do SSH-O KEX algorithms diffie held group one SHA one, and then I do Cisco at 172.16.1.20. And oh, okay, now I understand it. But the cipher's messed up now. Okay, so what about the cipher? How do I -C AES 1 2 CBC? Okay, so I knew you could always SSH like this. Oops, but I've got to, of course, enter in my password. But I was just, I guess, hoping that there was a way to have this kind of be the default. Okay, so I'm able to SSH. I mean, you can see, why I'd be frustrated with a book just kind of glossing over SSH. It can be a huge topic. I mean, if your keys don't match in size, if your authentication algorithm doesn't match, just so much can go so wrong. It's a really kind of thing that depends on a lot of things, a lot of things working in tandem. So it's kind of why I wish that book would have given more time to the subject. So I wish there was a way I could make that. Now this is a -O is the flag. -O okay, well. Yeah, I wish there was a way to make that persistent. Algorithms. Yeah, I mean, I wanna just make that the. Okay, so here we go. Kex rooms diffie Hellman group one CHA1. Okay, and now ciphers, and I will paste in the ciphers I did before. Okay. And now SSH keygen -A. And now service SSH restart GNS3. And now hopefully I can do it without these. Nope. Well, I guess it's not a big deal to just specify my KEX algorithm and specify my cipher every time I connect. It's kind of a pain in the A, but you know, I wish I could just make that the default and not have to worry about that. Let's try SSH key gen dash A. Nope. Oh, then restart the service. And now I magically need to put in my, nope, nothing. Let's see, vi or sudo vi c stage d. Yeah, I don't have that file, or if I do, it's not filled in with anything. Yeah, and I can't go across machines. I think I'll just use the dash O flag. So history type grep dash O. Oops. Oh, do I need a escape character? I do. Okay, yeah. So I can just use command 156. Command 156. And I have no problem getting in as long as I manually specify the KEX algorithm and the cipher. Kind of unfortunate I have to do that. I'm pretty upset by having to do that. But I can still use SSH. Really not a huge deal. I think it's not letting me log in. Oh, there we go. Yeah. I can still use SSH. Not a big deal. So yeah, a lot of time wasted to SSH, and the kind we're setting up too is just using encryption SHA-1, which isn't even all that secure. Even I think 256 has issues now. So, you know, this is kind of why I get upset when a book doesn't acknowledge that your environment you work in might not necessarily have everything you need, because you can see just how much of a pain it can be to get that. But you know, in the real world, you'll have the advantage of your coworkers who have been there and done that and can help you out. So that's something you definitely want to take full advantage of. There'll be some sort of internal documentation or kind of word of mouth. All right. So yep, we already did that part. So I used Viral Auto NetKit to automatically generate the initial configuration of the routers, which generated the default username Cisco and the password Cisco. Let's get out of here. Let's go in through Telnet like they wanted us to. Oops, we don't need this if we're using Telnet. All right. Notice that the user is already in privilege mode because of the privilege assigned in the configuration. The auto config also generated ETY access for both Telnet and SSH. All right, so let's see a pexpect example using the Python interactive shell. Okay, so we got everything they got. So we got one more command to do. If I can use my trackpad. I cannot use my trackpad. There we go. So it's going to be child dot send line exit. And as I'd mentioned before, this is a kind of important one because you're signaling the other side to terminate that connection. So it's going to go into TCP time wait state, and it's going to have its port open for an extra 60 minutes, or sorry, 60 seconds. And you're not going to do that. So if you're connecting to thousands of devices, that's important because you can get port starvation, um, especially so having it the remote side wait just one device wait one time is better than having your device wait 30,000 times. All right, so starting from pexpect version 4.0, you can run pexpect on the Windows platform, but as noted in the pexpect documentation, running pexpect on Windows should be considered experimental for now. In the previous interactive example, pexpect spawns off a child process and watches over it in an interactive fashion. There are two important methods shown in the example, expect and send line. The expect line indicates that the string in the pexpect process looks for is an indicator for when the returned string is considered done. This is the expect pattern. In our example, we knew the router had sent us all the information when the hostname prompt iosv-1 pound was returned. The send line function includes a line feed, which is similar to pressing the enter key at the end of the words you sent in your previous telnet session. From the router's perspective, it is just as if someone typed in the text from a terminal. In other words, we are tricking the routers into thinking they are interfacing with a human being when they are actually communicating with a router. The before and after properties will be set to the text printed by the child application. The before properties will be set to the text printed by the child application up to the expected pattern. The after string will contain the text that was matched by the expected pattern. In our case, the before text will be set to the output between the two expected matches, iOS v-1 pound, including the show version command. The after text is the router hostname prompt, child, send line, show version. I've include v, so we did that earlier. I closed the session though, as they told me to, but oh, well, let's fire that up and let's do this um, interactively. All right, so what is it telling us to do now? It's telling us to do that command. We just did that. So um, let's follow along again. If you're wondering about the B in front of the return, it is a Python byte string. So yep, yeah. And again, this book still hasn't mentioned help in Python, which I'm really upset at the book for, but yep, so it's a bytes object. Sure enough, you can do that help and get about it. You can also do type, something the book hasn't mentioned, even though it's meant to be a beginning Python book apparently. Um, so um, that will tell you, that will confirm that it is in fact that bytes object. What would happen if you expected the wrong term? For example, if you typed in username with the lowercase u instead of username with an uppercase after spawning the child application, then the pexpect process would look for a string of username all undercase from the child process. In that case, the pexpect process would just hang because the word username in all caps would never be returned by the router. The session would eventually time out, or you could manually exit out via Control+C. The expect method waits for the child application to return a given string. So in the previous example, if you wanted to accommodate both uppercase, lowercase, and uppercase u, you could use the following term: child.expect, and then like that. So let's maybe try that. So it's just going to hang now because it's not something that's going to come. The square bracket serves as an OR operator that tells the child application to expect a lowercase or uppercase u, followed by SCRNAME as the string. What we are telling the process is that we will accept either username with an uppercase u or all lowercase username as the expected string. For more information on Python regular expressions, go to that. Oh, okay, so they're all regular expressions. That's kind of cool. The expect method can also contain a list of options instead of just a single string. These options can also be regular expressions themselves. Going back to the previous example, you can use the following list of options to accommodate the two different possible strings. So that's kind of cool. You can also give it a list, and then it can expect anything in the list. So let's see. So we know it's not going to have any of these because we just did that earlier one. But let's see if the pound sign is going to be found. Nope. Yeah. There's no data for it to pull in yet. Generally speaking, use the regular expression for a single expect string when you can fit the different hostname in a regular expression, whereas use the possible options if you need to catch completely different responses from the router, such as a password rejection. For example, if you use several different passwords for your login, you want to catch %login invalid as well as the device prompt. One important difference between pexpect regular expressions and Python regular expressions is that pexpect matching is non-greedy, which means they will match as little as possible when using special characters. Because pexpect performs regular expressions on a stream, you cannot look ahead as the child process generating the stream may not be finished. This means the special $sign character $. Typically, matching the end of the line is useless because dot star will always return no characters, and dot plus will always return no characters, and the dot star pattern will match as little as possible. In general, just keep this in mind and be as specific as you can on the expect match strings. Let's consider the following scenario. So let's do that. So we're going to do child.sendLine show run, type include host name. And now we're going to do child.expect speed-1. And now child.before. Something is not quite right here. Compare it to the terminal output before. The output you would expect to be hostname iosv-1. I mean, that's what I got. I'm not sure what they're getting at with this because that is what I got. Oh, they didn't. Is this the point they're making? Because if this isn't the point they're making, this might be the second strike for this book. Yeah, this is going to be the second strike for this book. So you can see that they're expecting this to have gone through. But they even said in their own book earlier that, and you'll see they were doing it here. At least I thought they were. Huh. Well, I guess not. Okay, I guess I'm not sure what's going on. So yeah, I thought they were forgetting the carriage return at the end of the commands. But I guess you don't need that with expect or pexpect. So yeah, let's see what we get on the terminal. Okay, so that's what we get on the terminal. But taking a closer look at the expected string will reveal the mistake. In this case, we are missing the hash sign behind the iOS v-1 hostname. Therefore, the child application treated the second part of the return string as the expected string. I mean, the point they're just trying to make is I think, simpler than this example is kind of making it out to be. Just that expect matches on a character. So if your match isn't specific enough, you can match before you had intended to match, because you're not matching your full, because you're matching something you didn't expect to match. Like, it's a legit match, but you wanted to match something else. You just weren't specific enough about what you wanted to match. So it may seem like it matched the wrong thing, but it just matched the first thing you found. So you can see a pattern emerging from the usage of pexpect after a few examples. The user maps out the sequence of interactions between the pexpect process and the child application. With some Python variables and loops, we can start to construct a useful program that will help us gather information and make changes to our devices. Our first pexpect program, chapter 2 underscore 1.py extends what we did in the last section with some additional code. So let's make that. So what's it going to be called? Okay, so by chapter 2 underscore 1.py. User bin output select c equal sv dash 2 or sorry dash 1 prompt sv dash 1 and I like to format my code a little bit differently than they're doing here. So I'm just going to do it the way I like it. Okay. IP. 172.16.1.20. Okay. iOS v dash 2. Prompt sv dash 2 pound IP 2.16.1.21. Oh, and this is actually not the way I like to format it. I like to, yeah. All right. So now we're going to do username equals Cisco. Password equals Cisco. Now for device in devices.keys. Device prompt. This is child equals p select dot spawn comments plus. Oops, and I'll show you. This is how I like to write my code too. I like to do it like that. Plus this is this IP. And then we're going to have devices.device IP. I like to, I think I prefer it like that. Yeah, because then this goes, oh, why did this space over twice? Okay. Okay, so we've got that telnet statement. So now the next part is going to be child dot expect username dot send dot expect password. File.sendY password. File.expect device prompt. File.sendLine show version V. Expect device prompt. And then we're going to print child.before. Child.sendLine. So we've nested a dictionary in line 5. The nested dictionary allows us to refer to the same device, such as iOSB-1, with the appropriate IP address and prompt symbol. We can then use those values for the expect method. Later in the loop, the output prints out the show version output on the screen for each of the devices. So yeah, I like the way they did this. Nice and clean code. I like that they use the dictionary like that. So yeah, that's it. Charter instead of chapter. I'm going to rename that. Oops. All that just to do the rename command. Okay. Boom, we got it. It was a journey, that's for sure. Oh, and I don't have connectivity to the other device yet. I'm gonna have to T-shoot that. So let's do that. So device 2, let's see here. Show IP int brief. Yep, so we've got the IP on there. So let's do show int des. So the IP is up. So I guess I don't understand ifconfig. Oh, yeah. So it looks like we've got our IP address here. It's quite a bit different than what we would want it to be. So let's change that. 5 wired settings. So, yep, wired settings and IPv4. It's going to be 16.1.2. Apply. All right. Okay, that's interesting. Why is it unreachable from 16.1.1? They're the same subnet. Why is it saying destination host unreached. Let's see here. Oh, maybe it's not using this for some reason. Connect automatically. Yep, subnet mask looks good. Manual looks good. Link local only. Oops, and it looks like my computer just randomly went blank. Oh, okay, now it's back. Okay, sweet. So where's link local? Let's set up a gateway. 2.16.1.2. Why? Oh, that's really weird because it's got a gateway. Understand what's going on. Where's that 192? Let's see the. Oh, okay, that's for that one. Oh, it's still not. It still didn't change. Maybe I forgot to hit save. No, it's working now. It says it's applied. What about? Why is it not working to? So it's working for 20, but it's not working for 21, which I guess is kind of what I would expect. I wouldn't think that you would use the same subnet for each of these. I would think you use like a /30 or even a /31, but you wouldn't have them both be on a /24 like this. Yeah, whoa, so this is interesting. It looks like even .20 is no longer working for some reason. Yeah, and it was working before, so I don't know why that's no longer working. So if we do our file here, it's not going to work anymore because I can't even reach the thing anymore. Well, this video has gone really long, so unfortunately, I think I need a break. I'm going to have to stop it here. I think we definitely made it through this. So the next video, we're going to be pexpect features. So I'll remove the bookmark. Looks like it's already moved, add one here. And then hopefully we'll be done with chapter 2 soon. Yeah, we can get on to Paramika, which is where network automation, I think, begins. pexpect with Telnet, I don't think is an appropriate spot to begin a Python networking book, especially one that claims to be about mastering Python networking. So hopefully we're going to get done with that as soon as we possibly can. But until then, thanks for watching and stay tuned for more.